Alrighty, let's start scoping this out. Open some windows because it's beautiful outside. Just knocked over now. It's lovely. We get fresh air. This door's gonna slam itself shut in a little bit, and that's okay. So, what is the probability of selecting an 8th grade student? What is the probability of picking somebody random?
I found this on the web.
Not you. Yeah, so it's 180 out of the 545 kids that we took a survey of. So now we have our sibling that we just did not pay attention to what they like. So we know they're in 6th grade. What's the probability that they like skiing? 41 out of 155, yes. Because I know that they're in 6th grade, so I only care about the 6th graders. So 41 out of 155. So now we have another sibling that we pay even less attention to. I know they like skiing. We've gone on ski trips. I forgot what grade they are. So if I know my sibling likes skiing, what's the probability that they're in 6th grade? 41 out of 171. Because that blocks us off into the column as opposed to the row. Okay, so we're going to remember how to do these things. We need to know how to read these tables. Today, we are going to finish out the notes. Read your notes packet. There's, I believe, 3 pages left. We're going to finish them out. This is on page 18 in your notes packet. Page 18. All right, so what we have is we have a couple of different ways that we measure data. We've done a lot of median stuff, looking at those Dr. Whisker plots. We can also find the average, which we've done a little bit of. But there's a thing that we have in our data set sometimes that really tells us which one we should use for our data. And what that is that's called an outlier. So at the very, very top of your page, on page 18, it asks you about outliers. What is an outlier? An outlier just means a data point that is distant from the others. So a data point that is distant from all others. And we're going to see what happens to our measures that we've worked with when there's an outlier. We're going to see what happens, and then we'll talk about why that happens. All right, so we're going to start with the left data set over here. And we're going to find our mean. That's our average for these guys here. That means I need to get my calculator open, which is probably going to open on the wrong page or on the wrong screen. So work on finding your mean for this set of data. I got to switch my calculator over and then I can work on it with you. So how do I find my mean again? Add them all up. And then divide by how many there are. Please make it so this calculator is not tiny. There we go. All right. We're going to add them all up. We're going to divide by how many? So we've got our 3, 8, 2, 9, 7, 6, 8. So add them all up and divide by the fact that there are 1, 2, 3, 4, 5, 6, 7. Yep. So I got about 6.14. So our average, our mean, is 6.14. Then we're going to find our median. To find our median, we need to get these in order. So I'm going to put these in order here. We've got 2, 3, 6, 7, 8, 8, and 9. So what's our median? 7.
Good morning, Peck High School. At this time, all AP, Calc, AB, and BC students need to report to the main gym. All Calc, AB, and BC students need to report to the main gym. This afternoon, AP Computer Science Principals needs to report to G107 by 11:30. AP Computer Science Principals needs to report to G107 by 11:30. Thank you.
Okay, so there's our two measures of center. We've got mean and we've got median. We're going to see what happens if we take the same data set, but we put in an outlier of 50. Everything else is the same. So think of it as measuring shoe sizes. So this is shoe sizes in an 8th grade class, and that would be shoe sizes in an 8th grade class, and Jack comes to visit. Okay, so we're going to do the same thing. We're going to find our mean. I'm going to take my, that's not what it is. I'm going to add them up. So we've got my 3 plus 8 plus 2 plus 9 plus 7 plus 6 plus 8 plus 50. And this time we have 8 points here because Shaq came to visit. So we have 11.6 is our average this time. And then we're going to find our median. So we're going to, again, put them in order. We have our 2, 3, 6, 7, 8, 8, 9, and then 50. So where's our median? Between the 7 and the 8. So we're going to go 7.5. It's halfway between 7 and 8. Everything else was the same. Everything else was the same. I had 2, 3, 7, 8, 8, 9. 2, 3, 6, 7, 8, 8, 9. 2, 3, 6, 7, 8, 8, 9. The only thing that changed was the one term, that one piece, that one outlier. What happened to my mean? It increased a lot. If you think about it, if we look at our data set in order, without the outlier, my mean's right here. My average is right here. It's kind of in the middle. Not too bad. 11.6, it's saying my average is up here. That is way high. That's not anywhere near the middle of my data. So what we're going to say is at the bottom, underneath this box, you're supposed to, in your own words, say what happened to the mean and the median when we added in Shaq. What happened? The mean went real big. What happened to our median? Not much. He's still in the middle. Literally by the definition of median. So that jumps. I love that. I didn't give myself any space to write on that. There we go. Bless you. So outliers pull the mean hard, but barely move the median, would be how I would word that. So because of that, this would be the last question on this page, which I didn't write on here. How do we find the best measure of center when we have or don't have an outlier? With an outlier, so when shacks come to visit, when there's one piece that's way outside the norm. So with an outlier, it's better to use our median. With an outlier, it's better to use median. So if you have one piece of data that you just go, whew, that sucker's off. Something went wrong, or we got somebody way outside the norm visiting. When we have an outlier, it's better to use the median. When we do not have an outlier, with no outlier, the mean is actually a more specific center. It's very, very accurate. And what these are our measures of center. To measure center. So it's how we want to find the middle. If there's an outlier, we use the median. If there's not an outlier, we use the mean. That's all it is. If there's an outlier, use the median. No outlier, mean. All it is where is that center point? And then we're going to flip to the next page, and we get another new word, and I will tell you what it means, and we will never, ever, ever calculate, unless you choose to do AP Stats, because the formula for it is gross. What it is, it's called standard deviation. And what it measures is we go from that, this one talks about mean, so standard deviations on our mean is how far away from that mean is everybody hanging. Are I sitting really, really close to the mean, or is everybody real, real spread out? So we call it a measure of spread. So standard deviation measures spread. How spread out your data is from the mean. Standard deviation only works with the mean. you have already seen another measure of spread. Another thing that measures how wide our data is. If we think about the box and whiskers we did on Friday, the thing that measured how wide that box was that IQR, the interquartile range. So standard deviation and interquartile range are very similar. It's all about how wide is the data. How far apart is it? So the bigger standard deviation, the more far apart your data is. So which one of these has the biggest standard deviation? Let's see, we're going to give it letters so we can talk about it. A, B, or C? Which one is the most spread out? C. This has the biggest standard deviation. All it means is we've got our mean somewhere in the middle here, and everybody is really spread out. That is the weirdest shape I think I've ever drawn. Everybody's really, really, really spread out. Which one has the smallest standard deviation? B. Because if our mean is somewhere in the middle, everybody's real close together. That's all it is how far apart are they. So A has kind of the middleest standard deviation. We're not going to find a number. We are not going to find a value. You will never once calculate standard deviation because the formula for it is the worst. The worst. Standard deviation is terrible to calculate. When I do it with my other class, we literally do it on the computer. Because, the only people I know of in this school that calculate it by hand are in AP Stats. So all it is figuring out how wide it is. Standard deviation, you will hear that phrase. Actually, you'll hear it in college. They'll talk about grade averages on tests. That the mean score was this and your standard deviation is that. It just tells you how far apart everybody is. So if everyone is within 1 percentage point, standard deviation of 1, everybody's pretty close. If we had a standard deviation of 20, whoo, there was a big old range on that test. So then we're going to look at how does an outlier affect standard deviation. So if we think about our mean being in the middle here, kind of where that peak is, if we did not have that outlier, our standard deviation would look kind of like that. When it does have that outlier, remember it pulls our mean over, so our mean's now going to be, let's hope it's over here, and our standard deviation is going to go all wide like that. So the outlier falsely pulls our standard deviation out really wide. So an outlier will open your standard deviation falsely because there's only one piece open over there. It really shouldn't be affecting all that much. But since standard deviation works with the mean and the mean gets really, really pulled by your outliers, it gets really, really affected. So if we have an outlier, and we're using our median. So remember, with an outlier, we're going to use the median. To measure spread, we're going to use our box and whisker plot. So spread is going to be measured with the IQR, that inner quartile range. We calculated that on Friday. If we do not have an outlier, so without outlier, and we are measuring with our mean. We just talked about how we'd rather measure with the mean if we don't have an outlier because it's a more accurate center. But if we do have an outlier, we've got to use the median. So if we're using our mean, we're going to measure spread with standard deviation. So if there's an outlier, we use median and IQR. If there is no outlier, we use mean and standard deviation. That is 100% the difference between these two. It's going to be one of those things we're just going to have to remember and practice. So with an outlier, Shaq comes to visit, we got to use the median because he's throwing everybody off. If Shaq's not here, we can use the mean. It's a more accurate center. It gives us closer to the true middle because it averages. And we're going to practice looking at pictures and identifying which ones have outliers here and seeing which one we should use. So this is our last bit. So we've got these 3 pictures of data sets here. And we want to figure out which one's our best measure of center, what's our best measure of spread, and why. Not numbers, just which are we using, mean or median, standard deviation, and IQR. So what we're really looking at is, does it have an outlier? So on this first data set here, does this have an outlier? What do you think? Is there one piece that's really far from everybody else? Yes. Yeah. So this is an outlier. Since it has an outlier, what should we use to measure our center? The median. Since I used my median to do my measure of spread, we're going to do our box and whisker plot, just like we did on Friday. So our spread is measured with our inner quartile range. Because there's an outlier. So we use the median and the inner quartile range because there's an outlier. On this second one, is there an outlier here? No. So what's going to be our best measure of center? We're going to use the standard deviation, but that's not center. What's our middle? The mean. When I use the mean, we're going to use standard deviation. Because there is no outlier. So with little histograms like this, it's really easy to kind of spot an outlier. When we have a box and whisker, what we're really looking at is, are we matching? So are we both little, both big? If it's symmetrical, like if it's nice and tidy and even, that there's no outlier. If we've got one that goes off all wonky, there is a far data point over there pulling my max or my min to one side. So does this one have an outlier? Yes. Does it kind of look like a little teapot? Yes. So since it has an outlier, what are we going to use? Mean or median? Mean. Since we used mean, what do we use? Oh, sorry, I went backwards. Since we have the outlier, we use median. Outlier means we use our median. So it's one of those things that I just say it enough times today that I will flip them back and forth when I talk. Even though y'all said the thing, I said the thing. I wrote the wrong thing. Since we use median, we use our inner quartile range because outlier. Which we can tell because it's asymmetric. I won't ask you that, but that's how we knew. It wasn't all nice and neat and pretty and matchy. You didn't get a little square box and little bitty whiskers, or a little square box and really big whiskers on both sides, and they match. We like our kitties to match. The whiskers on this are we got one really long one really little one, and it goes tip over. If we have one really short one and one really long one, that means we've got to use that median because it is tipping us over. Okay, so that is everything you need for homework 5. That'll let you go finish homework 5. Module 10, homework 5 is the last homework of the semester. You've now done everything on it. Measure of center is determined by if there is an outlier. If there's an outlier. Okay, so if there is an outlier, use the median. If there is no outlier, use the mean. That is the extent of what we're doing with that. Okay? So use that as questions. That is it for notes for the year. That's it. So we've got our test currently scheduled for Thursday. And then finals are in about 12 days. I have to do my countdown. Yours is on the very last day. So yours will be in 12 days. 12 school days. It's coming, and it's coming quickly. Okay? I will get the paper reviews for the finals copied this week so you can have them when you're ready for them. There are Canvas reviews already up. There are Alex reviews already up. Use the tools at your disposal. Practice, get ready. We'll talk more about finals later this week. Okay?